Today we are going to be talking about Bertrand Russell, the man behind logicism, Russell's paradox, and neutral monism. Bertrand Russell was born on May 18, 1872 in Trelich, Wales. By the age of 3, he was an orphan and sent to live with and be raised by his grandmother. After completing his education at Trinity College, Cambridge in 1894, he went on to write his first book in 1903 called The Principles of Mathematics. Despite his interest in philosophy from the beginning, he was very interested in politics. After World War I broke out, he dedicated much of his time and effort to anti-war discourse and was even fined for authoring a criticism on the imprisonment of a wartime conscientious objector. In 1918, he was himself imprisoned for his pacifist beliefs, but while in jail wrote The Introduction to Mathematical Philosophy, which was published in 1919. His various philosophies, as we will see, are all closely related to his main proposition that our experience of the world can be reduced to simple logic, or the philosophy of logicism. In this video, we will review some of Russell's major contributions, beginning with his interest and role in logical positivism and neutral monism, a mathematical paradox he developed called Russell's paradox, and its importance for set theory, and finally, his role in the championing of logicism. Aside from questioning the validity of naive set theory, Russell was also a defender of the neutral monist stance on the mind-body problem. In the simplest way possible, this age-old philosophical question looks at the relationship between our mental and physical experience of the world. Luckily for us, it's easy to define physical. This mouse is physical. So is a dog or a cat. Physical stuff can be as big as a mountain or as small as a cell. But what exactly does all of this mean? Monists argue in the mind-body problem that everything can be broken down into stuff. Even feelings and mental states are stuff. Dualists say there has to be physical stuff and mental stuff. Russell believed, however, that there is only one basic neutral stuff out of which the physical and mental emerge. In a way, physical and mental states of experience are born out of a neutral substance that is, unfortunately, not actually knowable or provable to exist. In essence, while offering a compromise to the monist versus dualist debate, neutral monism is nothing more than speculation.
To put it simply, Russell rejected the idealism movement while defending his stance on neutral monism, that everything in this world is comprised of stuff in mental arrangements in one sense and physical in the other. He also believed that everything could be reduced to simple logic. In his first published The Principles of Mathematics, he attempts to explain that mathematics and logic were indistinguishable, and how mathematics can be logical by use of set, model, recursion, and proof theory. Set theory is studied sets in the form of a collection of objects. Model is the study of classes of mathematical structures such as groups, fields, or graphs. Recursion questions what patterns can functions be computable or non-computable, and proof are analysis by mathematical techniques presented in inductively defined data structures.
In 1901, Russell discovered, while investigating a theory of mathematics called naive set theory, a contradiction in the nature of the theory. What he wrote down has come to be known as Russell's paradox. Although it appears on the surface to be difficult to understand, listen closely and it might actually make some sense. At the basis of mathematics exists something called sets. The most common sets are even numbers and odd numbers. Simply put, what mathematicians understand about these two sets is that one, the even set, can always be divided by 2 with no remainder, and the other, the odd set, cannot be divided by 2 with no remainder. For example, 4 will always be divisible by 2 with no remainder, whereas 5 cannot be divisible by 2 without remainder. Where Russell's paradox emerges is when mathematicians introduce another pair of sets defined as sets that contain themselves as members and sets that do not contain themselves as members. Now, this might sound confusing, but if you follow along with the example we're about to explain, it might actually make some sense. Consider the following. Every library in Toronto is asked to list all of the books they possess in a single catalog. Some libraries will list the catalog within itself, and others will not. Now these catalogs, set A, those that do not list themselves, and set B, those that do list themselves, are submitted to the National Library. how should the National Library catalog these catalogs? If the National Library were to create a master catalog of all those catalogs that do not contain themselves, a contradiction emerges. What's the contradiction, you ask? If you don't include the catalog in itself, it is not a catalog that contains all books. Now, why is this important? For Russell, it is relevant because it undermines previous theory in mathematics that everything is definable by true or false. Or perhaps a better way of putting it would be that with the emergence of Russell's paradox came the idea that set theory is, in fact, inconsistent, and therefore there is room for error and contradiction. But why is this important to philosophy? As we discussed earlier, Russell believed in logicism, and logicism by nature must organize everything into sets of things. In order to understand the world and experience, one must be able to break everything down into smaller sets of things that eventually make up one whole set.
Russell came up with the theory of logical atomism, in where he states that everything in the world is composed of atomic facts, and each atom together in whole creates a universal truth which we gather through sense data. All these facts define what this object is, and it doesn't matter where we begin to characterize it. Take for example this mouse. Some atomic facts can be that it is black, hard, small, and light. We can instead begin stating it is lightweight and also black, regardless of what and when we analyze it. The truth is still the same. In the early 20th century, there was a group of philosophers and philosophically interested scientists called the Vienna Circle. These members used their advances in the natural sciences to redefine empiricism. There they devised the theory of analytical philosophy, a branch of philosophy which based theories more on analysis, mathematics, and natural sciences with the use of formal logic. Logical positivism was a movement in analytical philosophy whose thesis is based on verificationism, which sought cognitively meaningful truths through empirically verifiable statements. Basically, using one's senses and experiences, a truth can be verified through a single interpretation versus a truth that can be drawn from many interpretations, also known as tautology.
Bertrand Russell philosophy. Pace, efforts, and influence on mathematics are still relevant today. In terms of his influence on philosophy, his work with analytical philosophy has in many ways influenced behaviorism and the tools used in that field. Analytical philosophy is about breaking everything up into logical bits and understanding how those bits are experienced by us humans. Logical behaviorism, a stem of behavioralism itself, also looks at schematics of everything, or the logical meaning of everything we experience in our mental states. In mathematics, without Russell, we wouldn't have a very good understanding of set theory and its inherent flows.